Today we're going to go ahead and solve quadratic equations by using the quadratic formula. You should recall this from Algebra 1. You did learn this in Algebra 1. So the quadratic formula, just to review, is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And if you want to have a little bit of fun, go to YouTube and search the quadratic formula song, and you're going to get a lot of hits. You're going to see several people singing different versions of the quadratic formula. What we do need to do in order to solve this, though, is we need to have our equation in standard form. So I want you to think of it as we have our equation y equals ax squared plus bx plus c. And that's where this a, b, and c come from. They come from those coefficients from standard form. Now, what are we doing when we're solving? We're finding the value of x when y is 0. So we might make a note of that. Solving means find x when y equals 0. So what's happening then with my standard form is that the y is being replaced with a 0, and then I have the rest of that, the quadratic. So the very first step when we solve is to make sure that the equation is set equal to 0. So looking at this first example, I notice the 15x is on the wrong side. So I need to move it over. When I move it over, it's actually going to become a negative 15x. And I want to make sure it's in standard form, so it's going to be minus 15x in the middle there, plus 9 equals 0. Okay, so I have an a and a b and a c. And so this is where these numbers are coming from. A is 4, b is negative 15, and c is 9. And now we just take each of these numbers and substitute them into that formula up there. So we write it, x equals negative b. Well, b is already negative 15, so that just becomes a positive 15. Plus or minus the square root of, now we're going to do b squared. So what I go ahead and do when I'm doing this problem is I take the time to say, okay, what is b squared? Well, negative 15 times negative 15 is 225. So I'm going to use 225 in my equation here to save myself a little bit of time. It's a little bit less writing. Minus 4 times a, which is 4, times c, which is 9. And all of that's inside the square root sign. And then all over 2a, so 2 times a, which is 4. Now, if I type this entire thing into my calculator and try and have the calculator give me the result, it may or may not work. We have to remember that we have a positive and a negative symbol here. We also have to remember that we could have imaginary roots, which means that we would get a non-real as our solution on our calculator. So we're going to take the time to really break this apart and simplify it using order of operation. So I'm going to go ahead and simplify inside the radical first. So x equals, bring down my 15, plus or minus the square root of 225 minus, and then 4 times 4 times 9. 4 times 4 times 9 is 144. All over 2 times 4, which is 8. Okay, and then we'll simplify this one more time. And now at this point, and back here if you wanted to, you could actually type that entire thing into your calculator. And what you're going to find that you get is 15 plus or minus the square root of 81 all over 8. Now what you have to remember is that the square root of 81 is actually, 81 is a perfect square. So that breaks down into 9. So this equals 15 plus or minus 9 all over 8. So we're getting closer to the end here. Now, at this point, I separate this into two separate problems because I have to separate that plus or minus sign. So I do this 2 different times. The first time I do just the plus sign. 15 plus 9 over 8. And that top part has to be done first. And then I do it again, and I do the 15 minus 9 all over 8. So I separate it out. And this is going to equal 24 divided by 8, which is 3. And then 15 minus 9, it was 6. 6 divided by 8, and that reduces, we always want to reduce our fractions, and that reduces to 3/4. And now we're down to the end. So our final solution then, our solutions, is x equals 3 and 3/4. And that gives us our final solution. Now, yesterday's lesson was on discriminant. So if you realize, you'll notice here the discriminant that we were talking about really was that piece of the quadratic formula that was inside the square root, b squared minus 4ac. So when I get this all simplified down here, this 81, that 81 is the discriminant. And again, from yesterday's lesson, we should recall that that means because 81 is greater than 0, the discriminant equals 81. And because 81 is greater than 0, therefore, there are 2 real roots. So that then I look here, and this supports my answer, supports the nature of the roots, that 3 and 3/4 are both real roots. Okay, let's go ahead and do the next problem, number 2. So looking at problem number 2, this is already in standard form equal to 0. So I just need to identify the parts. So A is 12, B is 6, and C is 1. So we're going to go ahead and set up our formula. So x equals negative b, so negative 6, plus or minus the square root of b squared, which is 36. So I'm going to go ahead and write 36 straight in here, minus 4 times 12 times 1, all over 2 times 12. Okay, and we're going to go ahead and simplify again. X equals negative 6 plus or minus the square root of, and if you have a calculator, you could just type this straight. I'm going to do it in 2 steps. 36 minus 48 all over 2 times 12, which is 24. X equals negative 6 plus or minus the square root of, and then 36 minus 48 is negative 12, all over 24. Okay, so at this point, what you should recognize is that the discriminant is equal to negative 12. And since negative 12 is less than 0, I know I'm going to have 2 imaginary roots. Now, we need to go ahead and simplify this quadratic formula here, or quadratic expression, so that I have a radical that's not negative and that can be completely simplified. So I'm going to take the square root of negative 12, and I'm going to go to the side and simplify that. What does the square root of negative 12 equal? So I'm going to do 12 upside down division, 2 gives me 6. 2 gives me 3. And I have a pair of 2's. And then the 3 is left over. So this is equal to 2i radical 3. So we're going to go ahead and rewrite this as negative 6 plus or minus 2i radical 3 all over 24. Now, there's one more step that we like you to do here. When you look at these, there's 3 things happening. The top is a complex number. We have the negative 6, we have the 2i radical 3, and then the denominator is 24. And if you look at the 6, the 2, and the 24, they all have a common factor of 2. So we want to go ahead and divide each of those, reduce them each by 2. Just those 3 numbers, and you're going to do it to all of them. So the negative 6 becomes negative 3 plus or minus. The 2 divided by 2 is 1, so that's just I radical 3. And then all over, and the 12 divided by, 24 divided by 2 is 12. And that's the answer. That's where we want you to stop for this problem. So we still want this to be x equals, and there are 2 solutions because we have a plus and a minus sign. And let's see, there we go. And so that entire thing would be our 2 solutions. Now we can't get a decimal approximation for this because of the imaginary piece. We can't go any further with this. Okay, last example. We first need to get this equation equal to 0, so I need to move the 9 over. So this becomes negative x squared plus 6x minus 9 equals 0. So a is negative 1, b is 6, and c is negative 9. So we're going to set up our equation, our formula. X equals negative b, so negative 6, plus or minus the square root of b squared, so 6 squared is 36, minus 4 times negative 1 times negative 9. All over 2a, 2 times negative 1. Okay, we're going to simplify this a little bit more. Inside the radical, negative 6 plus or minus 36. Now negative 4 times negative 1 times negative 9 is negative 36. All over negative 2. 2 times negative 1 is negative 2. And then one more step in here. So negative 6 plus or minus the square root of, well, what is 36 minus 36? That's just 0. Do I really need that? Well, what is the square root of 0? The square root of 0 is 0 as well. So that's gone. And if that is 0, then guess what? I don't need the plus or minus. Well, let's take a look here at what we talked about yesterday with discriminant. So the discriminant for this particular problem is actually equal to 0. So since the discriminant equals 0, then the nature of the roots is that there is one real root. So what is that one real root? Well, going back then, if I don't need the radical, the square root of 0, and I don't need that plus or minus, then I just have negative 6 divided by negative 2, which equals 3. And so my solution is just x equals 3. That's the whole thing. And what that means graphically is that the vertex is actually at the ordered pair 3, 0. So there we have it. So go ahead and be ready to show these notes to your teacher tomorrow in class. Have a great evening.